So what we wanted to do tonight is give a discussion on the smart grid and that point. The utilities have been developing this and working this for a number of years, and it is only now recently has the people in the building sector and building services have realized that is an important thing that we will have to function on and worry about into the future. So I want to give you just an overview of what the smart grid is talk about some of the interactions of the buildings with the smart grid, particularly in some demand response type issues, and just maybe if we get some time, some potential vision for where future activities might go and where this might go on. The idea of a smart grid has been around for a while. At least we've heard that within our society, and for a number of years now, probably back in even into the 90s or so, there was some talk about eventually going towards something like a smart grid. But what it really is, what is a smart grid? There are various definitions that I've seen, and people describe that, and sometimes it might actually depend upon what your perspective is, what part of the industry you work in, what you would think of at that point. But in reality, or a good summary is that just really the smart grid is just a modernization of our current electrical grids, whatever country you're working with in that point, and however you spell modernized, I guess. Working from using information exchange back and forth between the utility, the users, and the technology that can help do that communication better. The idea is that you can more effectively produce, transmit, and use electricity wherever that's at. Every sector of the supply chain has different goals and objectives for that. I mean, the utilities obviously have a different stake in this and a desire for that than maybe the end users might. And one thought that I just realizing here of late is that the rules of the game in terms of how we purchase and how we generate, transmit, and then purchase electricity and use electricity are changing, and some of that is being facilitated by what we would call a smart grid, or at least some features of smart grid type technologies. So to help to kind of put in perspective of what things are doing and how this looks out. This is just this is sort of a somewhat of a traditional generation model of where it has been done for ages, where energy is being generated. It's then dispatched through the transmission lines. The utilities look at what the potential demand and response might be. Then they've developed the technology that has to match the demand. I mean, basically, there is no storage of electricity on the grid lines. Everything that's being used instantaneously is the same generated at the power plants, and so that matching at that point has been worked fairly well. In recent years, we've brought into additional factors involved with this. Has been some intermittent generation from renewables, from wind power systems, solar systems. That differs between other what we might call renewables, say hydro systems, that are fairly standard. We can control those. I mean, you really can't control the wind or the sun very well. You can maybe predict in advance what the generation capacity might be, but we can't control that. We can't turn a dial and make the wind go faster or make the sun shine brighter. But anyway, all that energy has been puts into just a normal transmission distribution lines, and it flows out to ultimately to the end users, ranging from industry or private residences, commercial buildings, what have you. And it's pretty much of a one-way street flow. Energy is being generated, transmitted, and being used, and then money's exchanged at the end for how much is being consumed. And it's a model that worked very well for a number of years, but now as different technologies come forth, and there's also different needs in terms of capabilities that we need to have and we need to put forth. So the future in terms of what some people envision what this might be is integrating both the intermittent generation and traditional generation, at least until the concept of how much is available. And then the idea of matching that supply with demand involves more than just the energy flow going downhill to the users, but actually put it in the sense of there's communication back and forth between the users and the utility. The utilities may say we need to cut down on demand, say if we're approaching a peak, or perhaps in terms of the situation where the communication between, say, an aggregator or the distribution of the energy might have to go back to the traditional sources. Say, we're getting a lot of intermittent generation coming from, say, wind farms or solar, and this is what our predicted. We would need to scale back just to make sure we match demand going from that point. So it becomes the idea of integrating renewable energies is it's a good thing, but this also makes it a little more complex in terms of matching the supply and demand with everything going about. And at the same time, we have a number of other technologies that are coming online that we want to think about in terms of things like electric vehicles, and when those electric vehicles are recharged can help alleviate perhaps some problems on the grid, but they also might create some more problems if everybody tries to do all that at the same time. And so we have a wide, basically almost like a web in terms of information flow and energy flow, and even looking at some future situations where some of the end users, like the electric vehicles or other devices, could actually be looked at as being almost like energy storage or energy charging stations for the grid itself, that we can send like energy to, and perhaps even draw energy from later on into the future as we go about. So we'll be looking at this, and then there's a research group I'm involved with here at the University of Georgia, and then we're doing some collaborations with a couple other universities in Europe in terms of looking at this overall as we look at one of the grand challenges, I guess, to try to, at least within our industry there. The idea of this generating electricity at that point, utilities have done a good job so far of at least developing the technology and the capabilities of meeting this, this smart grid concept. How they've integrated renewable energy systems into that grid, they've done a fairly good job of that. Probably only until the recent several years or so has this become an important topic, as the amount of renewable energy, from solar systems or wind power systems has made this important to begin to think about. And so, that's within the utility side, that's really a big area they're working with. And then, but within the industry that we deal with, with CIBSE ASHRAE, the built environment and, the building services there's a lot of work that needs to be done still in terms of preparing the technology, the equipment, and even in some ways just the mindset, adapting to that within the built environment. And things are changing so fast. We're basically developing what would be, or not necessarily our industry, but other providers are developing what we would call like the Internet of Energy Things. There's one of the appliance manufacturers that we're over here in the States that they've announced that by 2015 all their appliances that they will make and sell will be web enabled. And there's been others manufacturers that already have some of those now. So those are coming online, and not just not necessarily part of a building system, those small things like that, but they're connected to the buildings, and their interaction with that. It's something that really needs to be brought into, or could be brought into the consideration. So it's getting much more complex, and I think I just look at this and I see the interest that is being piqued within the industry, or people saying, hey, this is something we need to at least look at and be aware of. So I guess one of the purposes of this talk here today, going about that. So I want to talk about all the different stakeholders have different interests in the smart grid, and who the benefits and what the benefits are. The utilities will benefit because they can manage peak demand events or peak supply events more effectively. From their perspective, then they can more efficiently predict and control demand and integrate the supply with the resources that are availability. And then that ultimately leads to better reliability of their system, which utility, that's one of their primary objectives is maintain nearly 100% reliability of their grid and of their system. The users, such as building owners and building managers, I mean, for the purposes right now, you can primarily look at this as a cost minimization tool or cost management tool in a sense. There may be ways where we can schedule usages or when certain equipment is used and when it's not, to help minimize the overall energy cost. Also, potentially, the more disaggregating some of the data streams, energy consumption might help in terms of managing both from the utilities and the users themselves. And then overall, ultimately, society as a whole benefits because, looking at the ability to smoothly integrate, renewable energy into the grid and manage that effectively in this transition time process as we begin to have more renewables, ramping up and becoming a bigger percentage of the electricity supply in a number of countries around the world. That's something that we actually have to do. And I think the idea of a smart grid and also, the building owners and the building users and operators will have something part of that doing that. In some ways, if a renewable energy system, so the photovoltaic system is installed on a building, in essence, it's a distributed energy generation system, the building itself becomes both a user and a supplier, and maybe in the same context working from there. Just kind of put a little perspective in terms of many people, they may not be aware, especially from the CIBSE side, listen to this, the way the U.S. electric grid is divided up, there are three main connection regions. Texas tends to be off on its own, and they're not saying that energy cannot flow back and forth between those, but it is a little bit of constraint. Within each of those regions, particularly the Eastern Interconnect area, there's sub-regions where energy can flow fairly readily, but they're managed by different programs in their point. So there's sort of like domains in terms of where the energy flow is managed at that point. If you think about trying to put all that perspective and then look at where, for example, like this case, where wind resources available, they're in the middle part of the country. There's a wide range of wind resources available. It happens to be for a lot of farther away from population centers, and we as a country are looking at need to develop better transmission capability, carrying that energy from where it's being generated at to where it might be consumed at. And that's becoming, for this country anyway, is a problem that has already started to come in the fold. Within Europe and the European arena, right there, there's the group that is probably the best way of looking at in terms of smart grids and integrating that as the smart grid, this ETP smart grid forum. There's a website listing that point there, looking at some of their foreseeable future and where things are going. That is that within that group, they don't really see the building sector as being an important area for at least focusing of research areas. There's other areas they're focusing on for both transmission and distribution and consuming systems, but the consumer systems are more than just the buildings themselves, and that's probably understandable in the sense that there's different challenges and different demands on the grid in terms of demand response and other managements, say in the Europe, and as compared to most of the parts of the U.S. in terms of managing peak loads in the U.S. as with the cooling loads are the primary area where the utilities would deal with, and looking at demand response. There was a little bit of different challenge within Europe and those. I know there was an example here this past summer where within Germany, between the combination, it was just one of those days where you had a cool day, a lot of wind coming down from the north there, cooling loads were not really being required too much at all and generating a whole lot of renewable energy, and then integrating that within their fixed resources, and you can only tune those a power plant down so much. There was an excess of energy being generated compared to what the consumption was for the entire country, and that became there's a management issue there. So different things to focus on. And of course, most of the listeners here are aware of the challenges have been gone forth in terms of moving the smart grid forward in the UK. The installation of meters has brought some concerns up, and actually looking at that and seeing that there's some of the similar things have gone on here in the States in terms of people's concerns about installing meters, and a little bit of more of watching what is being used. And those are issues that I guess it's not surprising would come up in some cases. There's probably maybe a little bit different in terms of between UK and US in terms of the overall energy market, in terms of the separation of the entities that are involved in that there's some feel that make it a little harder to integrate into a full grid, but that's not saying a full smart grid, but that's really not saying that that's impossible. It just makes it a little more of a challenge. And the potential is there, to turn this and make this an efficiency of the overall system. It's just something that we'll have to have to work out and see how it goes from there. So if you look at in terms of the main components of a smart grid, both either now or into the future, I mean, smart meters are probably a big part of that, in the sense of being able to look at what the energy consumption is from the utility, can see that point, and then they can do some communication back between there, and looking at this on a not just on a hourly or monthly scale, but down on a very shorter time frame that they're looking at. There is need for, in terms of the technology and the components, some ways of communicating between the utilities and users. And there are, within the grid itself, there's looking at the logic and software involved in terms of integration at that point, and there's also communicating things for perhaps a demand response situation that's needed that the utility might request, and how that information is sent and communicated and integrated within a building and building automation system, so that it can be a much more automated process, is an area that's been undergoing work for the last 10, 12 years or so, and it's really now in the last couple of years has come forth with products and standards that they can smooth that information flow, from between the utility and the users and the equipment itself. And then looking at the concept of how the management of the load through perhaps energy storage and adding energy storage systems. So when energy is cheap or excess energy is being generated, or looking for maybe a low carbon energy sources, you can use more of that point, but maybe that's more than what you need right now at that instant, the ability to store that if possible. And then the other aspect of that would be a scheduling of the use there. So these are all aspects or components of a smart grid that will have to be looked at from. I just give you a little example of like one major utility here in the U.S. Recently completed a conversion of 100% of their meters, at least nearly 100% of the meters, to smart meters. There were a few holdouts of people that were unwilling to go about this point, but in many of the cases, in their users, they were basically given no choice, and that involved a fairly big number of that point. Over 4 million units were done. It took a 2 or 3 year time frame to get all that done, installed, and it's fairly massive effort from their part. And it's interesting if you look at why they do this. Or they've got this really smart grid in place, but really internally within that particular company, they justified that internally, that additional cost that's spent for basically just saving cost on meter reading. Instead of having a person going around every month and manually looking at a meter, writing that down, or even just if they were typing that in, recording that. Now the case that they can actually, you don't need that. You don't need those people to go around and do that point. So, they have that capability to do a lot more with this, but they're not at this time really are not moving forward too rapidly to doing so, because in their mind they've got technology in place, they've paid for it, and they're happy for right now. They're kind of waiting to see how everything else plays out in terms of smart grid development and where they might want to go with it, how they might want to use that. They're still sorting that out themselves. So you have to ask yourself sometimes, like, well, I'm a CIBSE member, ASHRAE member, or both, or other related societies. Why do I really care, or how is that going to affect my job? I guess in some way to go about this. First thing I can say is, it's coming regardless, whether we want it or not, or don't like it or not. In some form, the smart grid coming, and it won't be we'll wake up one morning and say, oh, we got a smart grid. That's not really the case of how it's going to come out. It's going to be more of a gradual evolution, and then it maybe in some ways sort of how like the internet came along, in the 90s or so. We heard about this, we saw beginning bits and pieces put together, and all of a sudden, eventually, in a period of transition over a number of years or several years, people just sort of adapted to it, and now it's part of our normal life, right? I mean, I'm communicating to you right now, sitting in my office in the state of Georgia, and we're doing this all over a web-based, presentation, where something this 20 years ago would have been strange. So, there's that, the idea that the smart grid's coming. We might as well adapt and make the best of it, and let's move forward there. In the current scenario, in terms of especially doing like demand response, industrial facilities have been integrated fairly well within utilities of responding to demand, but commercial buildings and residential buildings will be asked more and more to be involved with that. Commercial buildings are probably the one area that has the least aspect of input into this point. The main areas that we would want to look at this in terms of the involvement are probably primarily HVAC, perhaps to some extent lighting. There's HVAC and adjustments of some of that are probably a little less noticeable to the people, so lighting may or may not be as important about that. But the idea of communicating the energy requirements or the energy uses and adjusting demand based on what the grid says, you can do a lot of tweaks in there within HVAC that are fairly transparent, at least for on a short time frame, 15 minutes, half an hour or so, and you won't really notice that point. I look at this. I always try to look for opportunities. Since now my part of my career and be involved in academia and teaching the students at that point. What are some new disciplines that might come up? This idea moving beyond what was a hot item, several decades ago, an energy efficiency engineer, to now maybe a load management type of specialty. At that point of being able to adapt to that point. And some things, some of you may been some in contact, or maybe you actually work for companies that are equipment suppliers or vendors, and then realizing that these product lines are being converted so they can actually interact and participate in a smart grid. So there's a lot of reasons things have been going on. It's already in place, and I think it's probably us to begin to think about that and work from there. So let's talk now for a few minutes about just demand management. One, probably the main area that might be the benefit for the smart grid. There's a quote in here I saw that I thought was fairly apropos for this right here. In that sense, that the killer app for the smart grid is demand response and demand response management. The idea of managing peak demand or energy consumption, not just the total consumption, but actually instantaneous at that point, is becoming more important within building systems. Managing demand response may not have a big impact on the total energy used. In particular, say if you end up doing changing temperature set points, and then you go back and to reset to where they were before, there is some of a additional consumption that may have to take place later on. So in some ways, you're actually shifting demand as opposed to managing the total energy use. Not saying they can't. Some of these ideas would not. reduce the total consumption? They probably will, but it's not on a one-for-one basis in doing that. And really think with this, we need to get to the point where to look beyond just the one building's energy cost and that, and how we're going to justify that. In terms of demand response management, is asking the owner, am I just going to save money? Are we doing this just to help save money for the owner? And that may be part of consideration, but that's not the only consideration what we do. So I really look at there's three potential scenarios that we could possibly look at in terms of demand response. Perhaps maybe at least in looking at worldwide or globally, the idea of having a high demand relative to current supply is probably the number one to look at that. Looking at reducing the peak demand when you have high load conditions or grid stress. Typically that might be a summer cooling issue, although in some countries or some situations, maybe in winter heating might be where the peak demands might come about. Depends on where you live and where you work from. And that's that's probably one that most people would recognize as the most obvious one. Number B right here is pretty much what I just described a few minutes ago. What went on in Germany over this past summer, at least one day during that time frame, where you had a plethora of renewable energy being generated. That actually a situation that has occurred several times in parts of the U.S. There, in this case right here, it's in near regions where large wind farms installed nighttime when the energy consumption isn't as great and generating a lot of electricity, in a part of the country where you have to ship that electricity out to someplace else, and because of say real-time prices of that energy, in both those cases, both in Germany and then in that certain regions of the U.S., particularly like Western Texas, when these would occur, the cost of electricity actually can go negative. They're trying to relieve excess amount being generated. So, again, that's something that many people would look at as being a good thing in sense overall, in terms of how we're seeing higher contribution of renewables to the overall energy production. But these are things that maybe not, at least myself, didn't think was going to occur until a number of years from now, when realizing the future, I guess, is here right now. Another one, and it depends on where the country and situation, but might be also managing for low carbon energy production. That's a shifting around what's available and matching of the demand to match when low carbon energy production is available or energy supply is available. And it's somewhat of a combination between A and B, but it's also done from looked at from a different perspective and purpose there. So for items A and B, demand response scenarios are basically have led to market pricing. Utilities have developed the issues of how to handle that. One of the ways they do so would be by pricing of their electricity and letting the market supposedly take the place and adjust for that point. There's generally that would work fairly well, but then there's no guarantees that it works exactly the way they want to work out. It also leads to volatility in electricity pricing that is a possible problem for the end users, but also if you have a building that has the capability of foreseeing some of this, at that point it might actually become an opportunity for building energy managers and owners to take advantage of this to at least minimize their current cost. So there's opportunities available from a lot of places right there. So how building might interact within the grid, let's say it used to be a one-way street. Now buildings can receive and send electricity, so they're actually becoming generators themselves. If they have photovoltaic system or something installed on their facility, so they're generating some, they're sending that either to the grid or maybe using that internal in the building. And they're also receiving, assuming it's a grid-tied building, they're also receiving electricity from the grid. It still is now also becoming a two-way street in terms of information exchange. The utility communicates can send signals to their end users in terms of what they would like their operational needs, if they request perhaps a demand response event, the buildings can, also or soon be able to send operational status of their building systems back. So you can begin to see all this in terms of the different players talking and interacting with each other. And this Internet of Energy things, besides just our normal traditional equipment that we would look at the building managers, such as an air handling system or a chiller system, like that. But now we have taken it down to the other types of equipment involved in this, electric car charging stations that will be influenced in terms of how the energy response and how the energy is managed within a building. So another way to kind of look at in terms of demand response and fitting with the smart grid, you look at from the utility level, they're managing all these resources together and distributing there. You could look at in the sense of, and like where my employer, the university, has a large number of buildings in an area of a campus area there. We have some centralized system, and the electric grid is managed within our own university altogether. This chilled water systems or steam systems, and all that's being distributed to a number of buildings on the campus. And then within each building, there are individual pieces of equipment that are controlled by the building systems there. So looking at that as a method, the energy is flowing down, to all those individual pieces of equipment in the individual buildings, but the optimizing how that work out together almost becomes like an energy informatics type problem, to develop something that would work the best way. I want to spend just a few minutes here talking about within some green building programs, particular focus with those and within the states, and of what's new coming about in terms of incorporating demand response. LEED version 4, which becomes, I guess, officially effective here this month with this release, is actually includes a new credit point for demand response. And basically what it states is this: if you're building this building in an area that actually has demand response available, you sign up for it and participate in it, and you get a couple credit points. If a demand response available is not currently available from that utility, at least you have the infrastructure to take advantage of it in the future, and you have a plan for at least taking place and then being able to shed load by up to 10%. 10% is a similar number that the ASHRAE standard 189.1 for high performance green buildings has come about in terms of it's a little more simply stated in the sense that you have some system in place where you can reduce the peak demand of a building through active controls, load shedding, whatever, to again by that same 10% scenario. 10% seemed like a magic number that people creating those do. So I'm on the standard 189 project committee, so there wasn't anything magic about that. That just seemed something that was capable, and some studies have shown that was achievable. The International Green Construction Code, which that's the primary vehicle for green building, what could be adopted and brought into the building codes within the states, it also includes demand response there. Primarily, it says if it's specified by the local building code authorities that say our buildings here will have to participate in that, because if they're located in the case where the utility has no demand response program, why require it? So it makes sense in that concept there. If they do so, they look at, like with HVAC systems, reducing their peak demand by at least 10%, and also doing lighting again. So it's HVAC, lighting are two areas they're working from. They specify in there in terms of how that peak demand reduction would occur within an HVAC system in terms of, we look at this exactly the items we would pick anyway. Normally these are things that would be expected. One key point of this is that, they said you want to include control logic in that so that you don't get a rebound when maybe the demand response or demand concern lessens. You don't want to turn systems on all once at the same time and actually cause another problem going about this. One, we need to have, as part of this, you might envision, some way of communicating back and forth in there. So There has been the development over the last decade or so in terms of developing what's open ADR, open automated demand response system. It's a standard way of communicating between you utility or a provider and the building systems. And so you almost look like it's an add-on. It would be an add-on product to the vendor for making a building automation system or energy management system. There, it's the protocol that defines how the communication is going on. The first version of that standard was developed and tested within the state of California. The group that developed this donated the rights or the license at that point to this nonprofit organization that would basically manage that and work from that point. So now it's there's no concern or questions about this as a a for-profit venture, somebody trying to take advantage of the situation. So now it's sort of truly into the open software type concept there, or it's brought forth together and it's made public available so anybody can at least take advantage use of that. So the Open ADR Protocol 2.0 was released a year or so ago, if I remember right. And the idea of that is bringing out just the test case in one state and making that available all across the U.S. and also internationally. It's managed by the Open ADR Alliance in terms of it's comprised of industry members and people that are involved in working on it together. You kind of see how the way they would look at this, the communication architecture looks at both the energy generation sources, and then maybe a possible aggregator that's actually taking that energy sources and distributing those and providing them that, or the utilities themselves may directly send that energy between there. But in any case, there's the Open ADR2 would have a way of the communication back and forth between those two levels right there. So there within the Open ADR2 2.0 profile, there's three different profile specifications. The first one, profile A, is basically they call it, say, low-end devices, or basically only semi-smart devices that could do maybe some basic demand response services. It's fairly well suited for what we might think of standard demand response programs. They're a little higher on the sophistication level as you get to a profile B, a little higher end devices that can do more at that point, and also maybe doing some tracking and reporting, and then some feedback back and forth back to the utility at that point. So instead of just saying getting a signal and then doing a response, that might be done in A, B, profile B, or both. That type of setup would be more of a two-way communication. And then move into profile C is more sophisticated. That would be maybe the higher end overall building management system or higher computer control systems. So like maybe a data server that supports a number of markets in order from there. Where Open ADR has been employed or being tested at the point, there's a number of countries and situations there, pretty much becoming more of a global scenario or open item is available for that point. So if you haven't heard of this in the past, realize it is coming there. Just want to also make aware of that ASHRAE is in the process right now of developing a new standard 201 facility smart grid information model. It's a way to look at it is a way that how information would flow between different devices and that point. And it's still in the development stage. About a year ago, they had an advisory public review. The way the standards developed it within the process, that ASHRAE works from. They're put up for public review. They look at all the comments and the ideas. They incorporate those comments into the development of maybe a revision to the standard. So an advisory public review is not really being reviewed for publication. It was just saying, here's what we have so far, what do you think? And then they received a number of comments on that, and they were being incorporated and put forth such that when they actually publish such a standard, to be ready to work from that point. They're shooting toward, I had discussion with the chair of the committee writing this, they're looking for actually voting out and having an initial public review of this sometime in the early part of next year. So that will be coming more, down the road, down the future at that point. Just want to wrap up a little bit here with a few topics that might become important for a future smart grid. You know, the ability to predict both the supply and demand of energy, electricity in particular. You know, we need that. We need that, especially if we're looking at trying to um, integrate intermittent energy generating resources such as, you know, wind systems or solar systems. You know, maybe having the ability to foresee what tomorrow's weather forecast is going to be in this region, and we know we have X capacity of a wind system and Y capacity of solar systems installed in that region based upon what the weather is seen for tomorrow. What amount of energy generation could we actually expect from this? And then, you know, potentially we could look at in terms of what one person that I work with and talk with about maybe a consumption rights market, you know, not just the people purchasing and then working with the energy from the utilities and then under their terms, but actually you know, almost forming a market themselves in terms of buying and selling the rights to consume. Utilities are going to need to basically evolve their way of thinking from being more than just a generator of electrons and selling them to you, more the purveyors of electrons, in the sense that, you know, they may generate still a good bit of that, but other, you know, other energy is being provided to them by other distributed sources, and they are just the transporters of that energy, you know, to within the market. And, you know, there's still an opportunity to make money from that. It just it changes the business model, a business mindset. And then, you know, finally, you know, the rest of us in terms of building systems designers and equipment providers need to realize that, you know, this is coming, and, you know, look out for, okay, how can we adapt our building system design, or how can I adapt our design of our equipment lines to take advantage of these new technologies that are going to be asked for within the market. You know, and if you don't have those, sometime in the future, there, you know, you're going to be left behind in the marketplace. You know, losing market share if you don't bring that in. So with that, I think I pretty much kept on about schedule of what was being asked, and I think we can open up to questions here.
That's great. Thank you very much, Tom. That was incredibly informative, and I would say, despite what you said at the beginning, you do have certainly most of the answers. So thank you for that. I was very much left with the impression that we are lagging quite a long way behind in the UK on this, and I think this is why this is so useful for us to be, you know, to catch up with what's happening in the States particularly. I know there's quite a lot of work going on in Europe as well, maybe from a, as you said, from a slightly different approach. But it's very useful for us as CIBSE and ASHRAE members to keep track of where this is going in the US. We had a very useful session on this about 18 months ago, and you know, hopefully we will take on board some of the things you've been saying there, Tom. We're just waiting for some questions to come in from the audience, but I have a few of my own. If you don't mind, I'll you know, take advantage of the fact that I'm sitting in the chair and ask this. I mean, the first thing that occurred to me was you mentioned a lot. I mean, there's a lot of potential advantages with this technology, but a lot of people are approaching it from a cost perspective, and I guess in the end, that's what will drive and does drive most advances in our industry, is when people can see a cost benefit. And I just wondered if you thought the price of energy will have an impact on how quickly this will develop, because here in the UK we've got a sort of energy crisis going on. It's a huge political issue because our utilities are putting their prices up. Possibly in our industry we might think they're still not high enough to encourage more energy efficiency, but it's still a very, very hot topic in the UK, whereas in the US you're obviously benefiting from cheaper energy now with the shale gas revolution that's going on. So I wonder, do you think that will have an impact on how quickly this develops and how much demand there will be?
Yeah, it's interesting you bring that point, and there is within the U.S. I would say that the integration of smart grid technologies and concepts are probably more widely accepted in areas where costs are already higher. There's a wide disparity within different regions and different states of the cost of electricity, sometimes by a factor, even within the mainland U.S., within a range of over 2 times, maybe 3 times in some situations. So, in areas where it's higher cost, I've seen the acceptance of maybe something like this because, again, like you said, it's being looked at as a cost, a minimization tool from many of the utilities. It depends upon what their concerns are. I would say, give an example, the one utility I said that they've installed 100% smart meters at several years ago. In terms of that point, they were getting close to more demand constrained in some situations. I think they perhaps foresaw that they would take advantage of that and use this as to implement maybe some demand response measures, but because of downturns in economies and other things, and a couple other resources brought online, in terms of generation capacity, that's not as much a concern with them right now. So they perhaps have stalled out furthering the utilization of that smart grid and smart meter technology, just because it wasn't as much of a problem for that one particular utility. I see, in reality, really kind of this is going to have to be not as much of at least in the near term, not as much of a cost driven, but there may have to be some mandated type thing. It's interesting you talk about cheaper energy, and you're right. The natural gas becoming more readily available, the cost has come down significantly, or at least it has stayed down significantly. It dropped a lot during the 2008 when they had all the economic downturn, and it stayed down because of the higher supplies. But what utilities are doing, they're just using that as to supplement and retire maybe more expensive or operations are there. So their generating costs have stabilized. But my own local utility has a higher percentage of natural gas, but then they also just recently are talking about another potential rate increase for various aspects. So I would say our cost of energy is not going down a whole lot, just that the overall availability of natural gas is.
Thanks, Tom. Okay, that's good. We've actually got quite a lot of questions coming in now from around the world. So I'm. Yeah. Oh, are you still there? I don't know. I think I might have lost Tom. Well,
Stalling a little bit, so we get that.
Oh,
I'm
you're
sorry,
there. Hi, Tom.
Stalled for a second. Would you,
that's
yeah.
okay. You're back. That's good. It's a very specific question from Shaul Dakar in Israel. He would like to know if are you aware of any activity in Israel to do with smart grid, and is from the Israeli electrical companies, and do you have and does the fact that Israel is a small country and therefore very standalone, it's very isolated, would that be a good thing or a bad thing for smart grid development?
The first answer part of that is I'm not aware of, and that's not saying it does not exist. It's just that I've only recently, say the last year or two, have begun to delve into this and get more and more deeper into that point. I haven't had the opportunity, I guess, to look and see what's maybe going on in Israel. I see my email address is right there, so I would encourage that person asking that to perhaps contact me, and we can continue on that point. To answer the question about of a small country, I think my own, just my own personal opinion on that point, it probably makes it more important. Especially, I would assume that their electric grid is pretty much a standalone type of system, so the ability to manage that grid more effectively in terms of what supply and demand resources would be, and it's in a climate or a situation where the capability of having a significant amount of renewable could be in place, particularly say from sun, maybe perhaps even some from some wind there. So I would say that would be a fairly prime opportunity for Israel. But I'm not aware of what's going on there, but I would love to hear about it.
Well, yeah. Well, let's hopefully Cheryl can get in touch with you, Tom, by email, and maybe that's something that you can develop. That
Yeah.
sounds quite an interesting possibility there. I've got a question from Mariana Trisson. Hello, Mariana. Mariana is, I'm not sure where Mariana is, but she's asking, Tom, based on all you've been saying this evening, does this mean you think that the future is indeed electric, with consumption much higher than it is now, to accommodate electric cars and perhaps electric heating and etc. Funnily enough, I was at an event yesterday where some architects were talking about this, how we are trying to decarbonize the grid in the UK, which means going more nuclear renewable, but actually that means we'll have to extend the capacity of the grid because we're going to have a lot more electricity demand with electric cars and electric heating. So do you see that as the future, Tom? All electric systems?
I see electricity continuing in its growth of total energy consumption or total energy share for various reasons. I mean, at least besides say thermal energy for say solar thermal, the primary mechanism we have for renewable generation does generate electricity. It's a very convenient way to ship energy around. We have, over the last 10 or 20 years, we've seen increased uh, use of electricity for various things, for between computers and phones, and everybody's got their tablets on that point. And then the one thing that is really, I think, might have a significant impact on this is the electric vehicles. I mean, you already have certain countries and certain areas where a significant percentage of their transportation needs are taken up by electricity, from electric powered trains and what have you. But now we're getting the personal private vehicles, and then the use of those as being electricity, powering is an important thing. And I think that I just see that as being potentially a huge transition we're going through. Do I see a day where everything is electric, all vehicles? Yeah, maybe sometime far into the future, but there will be that transition working from that point. And this is something where if we as a society see that as a good thing, obviously the electric utilities they like that idea too, and so this may be one thing where it's a positive benefit for society can be brought on and adapted by the industry or certain people players in the industry willingly as opposed to being mandated.
Thank you, Tom. That's good. We've got a couple of comments from Mike Molina, who's a regular member of ours, who comments from over in the east of England. He's made some comments more along the lines of he very much was encouraged by what you were saying about building codes and so on in the US, and saying what we need in the UK is better enforcement, because if we were enforcing some of these demand reductions through our building regulations, then that would probably drive the take up of more smart technologies and a more, basically, as a sort of more intelligent approach. So thanks for that, Mike. We've got a question from Holland. So this is from Jordi van Laarhoven in Eindhoven. So good evening to you, Jordi. He's asking, what software would you recommend, Tom, to investigate energy storage in buildings connected to the smart grid? And he's given an example. For instance, houses equipped with a water storage tank, should they preheat the water during off-peak hours to heat their home and on their water for showers during the peak hours?
Okay, so I believe you're talking about the software to do the analysis to, in essence, optimize what that would be. Is that right? As opposed to the open ADR protocols is just a way of the communication with that point. Is that right?
Yeah, it's very much a software question. Yeah.
Right. I'm not aware of well, there are some that they're looking at being developed, and there's nothing I would really recommend. And obviously we have commercialization issues, I think, possibly to go from that point. I would say there's some people look at, and he brought the example of, say, electric water heater. There are some who want to say that perhaps The utilities could look at those themselves, and utilities may do some adjustments of when the water heater is on and when it's not, and specifically to manage their demand and actually perhaps modify their peak loads. They can maybe preheat some water and then let it ride through later on, and even a homeowner in the residence actually didn't use that water when then it's already been generated, So I don't have a good answer in terms of a recommended software package along that line. I think I'm not aware of somebody who's developed something like that. There are people that's still somewhat of a research topic, I guess, is where those type of things are at right now.
Right, thanks, Tom. Another question here from Mariana. She was asking about is the intention for the ADRs to be backward compliant? In other words, going to apply this retrospectively, or would actually be more that you'd be waiting for people to carry out upgrading works, and therefore they'd be applied to effectively new.
Yeah, when in my conversations with some of the equipment vendors and how they interpret open ADR, what that be, they're looking at it basically as an add-on product. Potentially, could go back to being backward compliant in terms of work from there, but I think that's primarily looking for is going forward. There may be some issues in terms of maybe it could communicate something, but it still can't function. And there, so and I don't know, maybe she was referring to the 1.0 versus the 2.0 version of that, or what. I did not, that type of backward compliance. But again, in summary, in my conversations when I spoke with people that are involved with development of products from a number of companies in the last year and a half along those lines, they're look at this as primarily new products going forward.
Yeah, I guess that makes a lot of sense. I mean, it's sort of the most practical way of applying it, isn't it, from moving forward?
Right.
Just to show the true international flavour of tonight, we've got a question from Africa, a question about Cameroon. It's quite a straightforward one, and I think you'll probably be quite positive. It's a Joseph Inau from Cameroon asking Tom. He has a similar question to the question about Israel, and is asking whether you see potential for smart grid in Africa, especially the Cameroon.
Well, I think when the person asks about the potential for a smart grid, in some ways, the potential exists for anywhere. And in some situations, if you're in say more of a developing country where more of the infrastructure is still being built out, now's the time to begin to consider that and put that in now, as opposed to going back and try to retrofit something on it's already it's already existing and put over the top of it at that point. I'm not familiar with the exact situation within the country that described Cameroon, but I just would foresee knowing what in generalizations would be the biggest issue right there is to look at there is an additional cost for including in essence upgrading from what you might call say a dumb meter to a smart meter. There is an additional cost involved. A lot of the communications still goes across the lines, the distribution lines, so that you don't have to install an additional management of a communication system, either via wires or wireless. That's already goes across there. So it's primarily at the endpoints or the nodes, I guess, in the network, if willing to adapt and include in essence an upgrade of technology beyond just the code minimum dumb system, then it's possible to do so. So it might become as much of a financial, the barriers as much as anything else. My recommendation would be to, a country such as what we're referring to, is if I think there are a lot of advantages to managing that, and including the resources, to any country. And if you're in the process of developing and building up a grid, why not do it right the first time?
I'm not sure if we
Okay.
lost you in there.
Oh, yeah. Well, I saw, remember they had that pause issue when it was last week, and
So that was my fault. I forgot to unmute myself. Apologies there.
oh, okay.
So I was just going to say, Tom, thank you very much. We've come pretty much to the end. I just had one final comment, I think, from Mike Molina saying, which is really more of a comment and in support of what you've been telling us. Mike was saying that for the UK, a key area should be the deployment of automated dynamic demand management for end users in non-critical systems, and that would be obviously a way of us bringing this in without scaring the horses, as we say over here, when people are worried that we're going to be coming in and turning their fridges off and that sort of thing.
Yeah, well,
So,
I just kind of say, just final comment there. I'm working on helping develop a demand response program for my own university campus, and we're making great strides, do everything we can to keep transparent to the normal occupiers in the building.
Yeah, that's great. Thank you very much, Tom. It's been a fantastic evening. We had a couple of comments just come in and said that was a great topic and people learned a lot. And we had people online from around the world